Welcome back. This is Mr. Hassan's Maths channel. I'm now answering a question from a Solomon H paper from Mechanics M1, Mechanics question from the Solomon collection of papers, which is question number 5 from that paper and question number 7 from my end of topic worksheet, number 6 on momentum and impulse. All right, so this question actually is few different topics mixed into one question, but I've put it under this particular topic because we have covered, by the time we've done momentum impulse, we've had covered those other topics beforehand, and not the other way around. So anyway, a sledgehammer of mass 12 kilograms is being used to drive a wooden post of mass 4 kilograms into the ground. A laborer moves the sledgehammer from rest at a point 0.5 meters vertically above the post with constant acceleration 16 meters per second squared directed towards the post. Find the velocity with which the sledgehammer hits the post. So basically, here we got this. So we got the ground here. Okay, and you got this post that is being, hammered into the ground, basically. And there's a sledgehammer that is coming down, and it's going to hit the post. Okay, so just say that the guy who's hitting the post into the ground, he raises the sledgehammer, a certain height above the post, and they're telling us that height is 0.5 meters above the post. So that's how high he starts above the post. So the sledgehammer is coming from there. It's going to hit the post, right? So it says here from rest. So its speed at this point is 0 meters per second. We want to find the velocity with which it hits the post, okay, and it's accelerating towards the post at 16 meters per second squared. Now here we don't have to consider the weight of the sledgehammer because that's all factored in with this acceleration. We know the acceleration with which it says a constant acceleration with which it's hitting the post. So the guy is actually pushing this or pulling this sledgehammer down onto the post. So it's not just falling through under gravity. He's also giving it some force as it's coming down towards hit the post. So this acceleration includes the factored in of the weight and everything else and the force that he's pushing down with, all kind of together in one thing. So that is acceleration. We don't have to consider the weight of the object at all. So we have S suvat, all right, it's constant acceleration of 16 meters per second squared. I'm going to take down as positive as this thing is moving down initially. So therefore, it's moving 0.5 meters downwards, which is positive. So 0.5 meters is S. U is 0. V is what we have to find. T we don't know. So we're dealing with S, U, V, and A. So that's going to be using V squared equals U squared plus 2AS. We need to know the equations of motion, and we need to know which ones to apply. So here we're dealing with V, U, A, and S. So that will be V squared equals U squared plus 2AS. So we're going to find what V is. So V squared equals U squared, which is 0 squared, plus 2 times A, which is 16, times S, which is 0.5. So you end up with V squared is equal to 2 times a half gives you 1. So you're left with 16. So V is equal to 4 meters per second. All right. So that is the velocity with which the sledgehammer hits the ground. Now it's saying find the velocity, so it doesn't say find the speed, so I'll say 4 meters per second, okay, towards the ground. It's kind of obvious, but because I said velocity, I put it with the direction as well. Okay, so that's how we can deal with that first part of the question. Now for the next part of the question, part B. It says, when the sledgehammer hits the post, they both move together with a common speed v. Okay, when the sledgehammer hits the post, they both move down, okay, with a common speed v. Show that v equals 3 meters per second. So this is the momentum and impulse part of the question. Okay, so we can think about, the sledgehammer just before it hits the post. There's a post there just before it hits the post, and we can think about it just after it hits the post, or just once it hits the post. Okay, we can think of this as before, and we can think of this as after. Okay, so we know that before this is moving downwards 4 meters per second. This is not moving, the post is not moving. After, and this has a mass of 2 kilograms? The sledgehammer has a mass of 12 kilograms, 12 kilograms. And the post has a mass of 4 kilograms. So after, we can consider them as one particle, one combined particle. So after, I consider them as together 16 kilograms, okay, with a common speed, and they're going down with a common speed. They're moving with that common speed. All right, so that's before, that's after. So let's use the conservation of momentum. The conservation of linear momentum, the total momentum before the collision and after the collision must be the same. So here we've got 4 times 12 plus 0 times 4, okay, is equal to 16 times v. So this gives you 48 equals 16v. So therefore v is equal to 48 over 16, which is equal to 3 meters per second. Okay, so we say v is equal to, as we're asked to show, 3 meters per second. So in this kind of question, you have to show your steps very clearly, right? So that's why I showed all these steps here, just to make sure, because they say show that. When they give you something that you have to show, you have to make sure that you mention very clearly how you got it. Okay, so there's part B. Now for part C, it says, as a sledgehammer hits the post, the laborer relaxes his grip. Okay, so as a sledgehammer hits the post, the laborer relaxes his grip and applies no further force. The sledgehammer and post are brought to rest by the action of a resistive force from the ground of magnitude 1,500 newtons. Find in centimeters the total distance that the sledgehammer and the post travel together before coming to rest. So now the sledgehammer and the post are kind of moving as one kind of object of a mass 16 kilograms. And let's think about first the forces acting on this object. Now the forces acting on this object, once the person has relaxed his grip, is just its weight. It's just the weight of the object now, right? So you've got the weight of the object acting down, and acting up are the resistive forces from the ground, which is 1500 newtons. So those are the upward forces, and the downward forces are the weight, 16 g newtons. Right, so these are the forces acting on the object as it is going through the ground after the guy has hit it with the sledgehammer and he has not applied any more force. It's just its weight. Okay, now that is, acting downwards, and the reaction, the resistive force is acting upwards. So it's going through the soil. We will see how far into the soil it goes. So for us to do that, we have to basically find the acceleration. Okay, so constant, we can say constant resistive force 1500 newtons, so the acceleration will be constant. So let's find the acceleration. Well, we can find the acceleration by resolving the forces downwards. We can say that the resultant force is equal to the mass times acceleration, and the resultant force, if we're taking down as positive, is 16g minus 1500, and that's equal to the mass, which is 16 times acceleration. So we can say the acceleration is going to be 16g minus 1500 over 16, and of course it's going to be a negative because it's going to come to rest. That's definitely going to be a deceleration. So 16 times 9.8 minus 1500 divided by 16. That gives us minus 83.95 meters per second squared. So now we have enough information to work out the distance that the sledgehammer and the post travel. We can now use our suvat equations with what we found. We want to find S. We know that the initial speed of these two together, when they first started, was when they first started moving. When we first considered the movement, was that speed with which they started moving down was 3 meters per second squared. That's how fast they're moving when they combined as one object, as we said. We want to find how long it takes for them to come to rest. That's going to be 0 meters per second. The acceleration, as we just worked out, is negative 83.95 meters per second squared. Now remember, we're taking down as positive, and the acceleration is upwards, basically. It's decelerating. It's like the resistive forces are greater. So that's why it slows down and comes to rest. The time we don't know. So again, we're dealing with S, U, V, and A. So again, it's going to be V squared equals U squared plus 2AS. And we know this is 0. We know this is 3. We know A is negative 83.95. And we've got to find what S is. Okay, so this is 3 squared, sorry, 3 squared. Because that's U is 3, that's 3 squared, that's going to be 9. So we can say that minus 9 over 2 times negative 83.95 is what's going to give us S. So S is going to equal, we're going to have negative 9 over 2 times, oops, we have negative 9 over 2 times 83.95. That's negative as well. All right, that gives you 0.053633. 0.0536033. That's in meters. So we want to change it to centimeters. We multiply it by 100, so we end up with 5.3603 centimeters. So we can round that to 3SF, in which case it would be 5.36, or we can round it to 2SF, in which case it would be 5.4 centimeters. Either of those are perfectly fine. As I said, when you're involving G in your calculations, you don't have to go more accurate than 2SF, but putting it to 3SF is also acceptable when you have used G in your calculation. So there's the answer to part C. The last part of this question, which was what the student actually was asking about, involves finding the acceleration or the deceleration of the object by using resultant force and then using suvat to find how far it's traveled into the ground. Okay, so you can think of it as one object just with the weight acting down on it, and it's being opposed by the upward force, which is the resistive forces as it's going through the ground. Okay, so there concludes this question number 5 from the Solomon H paper, question number 7 from my M1 end of topic worksheet on momentum and impulse. I hope that was all clear. Thank you for watching. Other questions from this paper can be found, from the Solomon H paper, can be found in the playlist that will appear in this region here. Other questions from this particular worksheet on momentum and impulse can be found in the playlist in this section here. M1 questions on momentum and impulse can be found in this playlist, and you can subscribe to my channel by clicking on the link over there. Thank you for watching, and see you soon.